In this lesson we discuss cobalt-27. Cobalt has played an important role in history of pigments because was used starting from the 15th century for smalt pigment, where smalt is a cobalt-containing glass that was pretty popular because of its low cost and because it was a very good dryer for oil paintings. Then in the 19th century, cobalt was used to produce a very fortunate series of blue pigment, starting with cobalt blue, cobalt cerulean blue, and then the cobalt chromite blue, that was a cheaper version for the cobalt cerulean blue. Those were pigments used by impressionists, post-impressionists, so from the 19th century onward. Still today, cobalt pigments plays an important role. Cobalt-27, these are the X-ray lines. So we have K alpha at 6.9 and the K beta is at 7.7 keV. As usual, we want to have a reference baseline, so we have the cube, the metal cube. Cobalt, the K alpha line, we said, is at 6.9. With the low keV setup for the X-ray tube, we have a very strong signal. So we are over 130,000 counts. When we do the routine setup, so this one, the count is over 20,000. For cobalt, we can use the routine filter setup, that is our preferred one, because we can see all the spectrum again. Also because the pigments based on cobalt, they have cobalt in a good quantity, so it's a dominant element, so that even if the signal with the routine filter setup becomes a little bit low, we can still see it. So let's see an example. We start with smalt. Smalt is a glass containing cobalt that gives the blue color. The black one here is the spectrum of smalt using the low keV filter set. We have more than 11,000 counts, so a very strong signal. When we use the routine filter setup, we are a bit lower than 1,000. Now, this 1,000 counts is still enough to identify the pigments, okay? It's well over the noise of the instrument, so is acceptable. So we tested the other cobalt-based pigments in our pigments checker. So you see, there are plenty of pigments based on cobalt, and we over here we listed them starting with the ones that gives the strongest signal, XRF signal. So we start with cobalt violet, cobalt blue, cobalt chromite blue, smalt, cobalt yellow, cobalt titanite green, and cobalt cerulean blue. Cobalt violet has the strongest signal because we just have here cobalt, and the other elements are among the most light elements, so they don't play a role in XRF spectroscopy. So it's like there is just cobalt. So cobalt violet has definitely the strongest signal. When it comes to cobalt blue, you see cobalt blue has also aluminum that is detected by XRF. So in this case, we expect the signal of cobalt to be less. Then we move to cobalt chromite blue. We have cobalt and chromium, an heavier element. Then we have smalt, where there is cobalt potassium, so there is less of this cobalt, and so on until we get to the cobalt cerulean blue, where we have cobalt and tin, that also is very, very heavy tin itself. Most of the X-ray will interact with the tin and less with the cobalt. That's basically a rough idea what's happening. We actually can measure this approach, so I have an actually idea what's going on. So over here you see basically I listed the spectral XRF spectra of these pigments. Cobalt violet is the black one, the counts of the K alpha line, peak is 5000. Then all the way down at 1500 we have cobalt blue. Then on the other side here we go basically around 1000 where we have cobalt chromite. When lower we have the smalt, we have cobalt yellow, cobalt titanate, green, and the last one over here, this one is a cobalt cerulean blue. That is a bit over 300 counts. The bottom line is that when we use the routine filter setup, so the R over here, if we have cobalt cerulean blue, it's just 300 counts. It's still detectable, but definitely in this case will make sense to test the LK, the low cave filter set, to double check that there is no cobalt.